I'm going to talk to you today a little bit about numbers, something that we should already know a little bit about, but I'm just going to refresh your memory. The set of complex numbers consists of two groups, one called the real numbers and the second called the imaginary numbers. We already know all about the real numbers, and you don't know anything about the imaginary numbers. That's going to be something for later on this year. The real numbers, so we're going to talk about the real numbers. The real numbers is split into two groups. One group called the rational numbers and another group called the irrational numbers. The rational numbers are the numbers that we are most familiar with. That would be the integers, which would include positive and negative whole numbers including 0, fractions, mixed numbers, terminating decimals, and repeating decimals, all of which I would think that you would know something about. An example of an integer would be something like 5. An example of a fraction would be something like 3/5. An example of a mixed number would be something like 1 2/3. And a terminating decimal would be, if we write 1 2/3 as a decimal, it would be that would be a repeating decimal. So we're going to write it as a repeating decimal, 1.6, and I'm going to put a bar to show it's repeating. And a terminating decimal would be something like 1.35. So we know about irrational numbers, but they're definitely not the numbers that we're most familiar with. The irrational numbers, a very, very popular example of an irrational number would be the number pi. Pi is an irrational number dealing with circles, and it is approximately 3.14. Another example of an irrational number would be something like the square root of 2. If we punch the square root of 2 into our calculator, we would get a non-terminating, non-repeating decimal. So the definition of a rational number is any number that can be written as a fraction. So all of these numbers below that I've written can be written as a fraction. 5 would be 5/1. 3/5 is already a fraction. Mixed number would be 5/3. And this terminating decimal would be 1 35/100. And the repeating decimal would be 1 2/3 or 5/3. So we've got this couple of sets of numbers that I want you to be familiar with. We need to be familiar with the set of rational numbers. Rational numbers are those numbers that can be written as a fraction. We also need to be familiar with the set of whole numbers and the set of integers. So I have listed those for you below. So one thing I would expect that we could do is order the following numbers from least to greatest. So you can go ahead and do that. Okay. Another thing that I want to review is a few properties that we know when dealing with numbers. The first property, and these properties work for addition and for multiplication, the first 4 anyway. The commutative property says that a plus b is equal to b plus a, or a times b is equal to b times a. So that's saying that if I switch the order of the two numbers when I'm adding or multiplying, I will get the same answer. 3 plus 5 is the same thing as 5 plus 3, and so on. The associative property has to do with grouping. It has to do with the way numbers are grouped. When we're adding or multiplying more than two numbers, the order in which we group the numbers does not matter. 3 plus 5 plus 2. If I add 3 plus 5, I'll get 8, and then 8 plus 2 is 10. Or if I group the 5 and the 2 together, 5 plus 2 is 7, and then I add 3, I get 10 either way. They're both 10. The identity property is a little bit different for addition and multiplication. The identity property for addition, we call that additive identity, says that any number plus 0 would be itself. And then the multiplicative identity, that would be multiplicative identity, says that any number multiplied times 1 would be itself. We've also got the inverse property. It's different for addition and multiplication, so we need to make sure we know the difference. The additive inverse property says that if we add two opposites together, we get 0. 5 plus negative 5 is 0. 1/5 plus negative 1/5 is also 0. The multiplicative inverse property says that if we multiply a number times its reciprocal, by its reciprocal, we will get 1. 5 times 1/5 is 1. And 2/3 times 3 over 2 is also 1. 2/3 times 3 over 2 is 1. That's the multiplicative inverse property. And I would imagine that we're all very familiar with the distributive property. The distributive property we use a lot in algebra. So I have 4 different examples here, and we're going to name the property. This first property, notice we are adding 3 numbers together, and I have changed the grouping. So this is the associative property. The second example, I have 1 over 32 times 32 is 1. So what I'm saying is that when I multiply these 2 numbers together, which happen to be reciprocals, I get 1. So that is the multiplicative. And we want to distinguish between additive and multiplicative here. Multiplicative inverse property. Okay, and then the third example says that some number times 1 is itself. 8 times 1 is 8. So that would be the multiplicative again, because we want to distinguish, because the additive identity is different from the multiplicative identity. So that would be multiplicative identity. And then the last example looks like it might be associative, but I have not changed the grouping. Notice I have an AB together and a 5 and an AB. And all I did was switch the order of the 2. So what I have here is called the commutative property. And the last thing I want to talk to you about is a little bit of unit analysis. Converting units, something very, very important that I think is a review for all of us. It says to perform the indicated operation. So what we're doing in number 1 is we're adding 2 units together. We're adding 685 feet plus 225 feet. So what we're going to do is we're going to add 685 plus 225, and we get 910. And when we add 2 units together, the units do not change. So feet plus feet will give us more feet. But look at number 2. Number 2, we're multiplying units together. We have hours times kilometers per hour. The division sign here is when we say per. So per always means divide. So we're going to multiply 2.25 times 60, and we're going to get 135. And when I multiply my units together, they are going to change. So what happens is we've got this fraction over 1, and we notice that anything divided by itself is 1. So we've got hours divided by hours. We're going to reduce to 1. And all we have left are kilometers. So we've got 135 kilometers. And we're going to do the same thing for the next one. We are going to multiply across. I just say when we multiply fractions, and then we're going to divide. So we've got 66 times 3600, and then we're going to divide that by 5,280, and we get, hold on a second, divide by 5,280, and we get 45. So we get 45. Now let's check our units. We remember that anything divided by itself is 1. So I see feet divided by feet. Remember, something in the numerator with something in the denominator is what we can reduce. I see seconds divided by seconds. And so what do I have left? Miles per hour. All right, so now let's do a conversion. We're going to do exactly the same thing, but we're going to actually set it up ourselves. Convert 75 miles per hour to feet per second. So we're going to start with 75 miles per hour. Remember when I said per, I'm going to divide. So we've got 75 miles per hour, and we're going to multiply that by some unit converters because I want to convert miles into seconds, and I want to convert, miles into feet and hours into seconds. So I know that there are 5,280 feet in 1 mile. So I'm going to say 5,280 feet for every 1 mile, and I put my mile in the denominator so that I can cross it out with the other one in the numerator. Miles divided by miles is 1. So now my units are feet per hour. So I'm going to multiply it by another unit multiplier, and I know that there are 60 minutes in an hour and 60 seconds in a minute. So there are 3,600 seconds in an hour. So I'm going to say in 1 hour, there are 3,600 seconds. Notice I put the 1 hour in the numerator because over here we started with hour in the denominator, so we're going to cross those out. Now I'm in feet per second, so all I have to do now is multiply 75 times 5,280 and then divide that by 3,600, and I get 110, and my units are feet per second. And lastly, we have one more example. Lastly, we're exchanging $500 in French francs. The exchange rate is 6 francs per dollar, 6 francs in every dollar. Assume that you use other money to pay the exchange fee. How much will you receive in francs? So we start with $500, and that would be $500. It's not dollars per anything, so it's just dollars over 1. And we're going to use a unit multiplier because I know that in $1, there are 6 francs. Notice I put dollars in the denominator because dollars was in the numerator in the other fraction. I want to be able to say dollars divided by dollars is 1 because I'm converting to francs. So I'm going to say 500 times 6 is 3,000, and my units are francs. And then when you return, let's look at part B. When you return, you have 270 francs left. How much will you get in dollars? So we have 200, and when we get back, we have 270 francs. So that's what I'm going to start with, and it's not francs per anything, so I'm just going to put over 1, and I'm going to use a unit multiplier. And remember, I want to put francs in the denominator over here because we want to be able to say francs divided by francs is 1, because we're going from francs back to dollars. So I know that there are 6 francs for every $1. So I'm going to cross out my units. Francs divided by francs is 1. And now I'm in dollars. So now I know that I have to do 270 and then divide that by 6, and I get $45. So when you get back, you get $45 back.